Hi everyone, this is Matt Touchot with Intro Stats, and today we're looking at a problem from my book, Intro to Statistics for Community College Students. This is section 4D as in dog, number 30. So let's read the question together. An online sports magazine wrote an article about the favorite sports in America. It said that 43% of Americans prefer football, 23% prefer baseball, 20% prefer basketball, 8% prefers hockey, and 6% prefer soccer. And then we have some random sample data, and they asked what their favorite sports was, and we got these observed sample counts. Use a 5% significance level to test the claim that the proportion match the distribution claimed in the magazine article. Okay, so we're basically we're testing that this sample data matches what they said in the article, these percentages here. So what would this is obviously a goodness of fit test. We have multiple percentages from more than just one or two groups. It's 1, 2, 3, 4, 5, 6 different percentages. So again, this is not saying that all of these percentages are equal. They're saying each category, each group has its own unique percentage. So if we're going to write that, usually write something like this. The P or pi for football was 43%, 0.43, baseball was 0.23, basketball was 0.2, hockey was 0.08, and soccer was 0.06. And this is, by the way, the claim, because they're saying that they want us to kind of check and see if this is correct, if what they said in the article could hold. If at least one proportion could be not equal, right? Not equal. All of these are not equal to each other, but they could be not equal to these percentages that were listed in the article. Whereas at least one of those is wrong. All right, we have 1, 2, 3, 4, 5 groups, that is. So degrees of freedom would be 5 minus 1 or 4. Notice they gave us the printout from StatCato, which is good. So we have our expected frequencies. This is our expected counts, what we expect to happen if those percentages listed in the null hypothesis were correct. And if you notice, all of them need to be bigger than 5. This one's getting close. This one, our last group was 7.8 expected count, but it is above 5. So we are going to be okay in terms of passing the assumption of expected counts at least 5. It did say it was a random sample, so that's going to pass that. And are they independent? Well, a small random sample of adults out of millions of Americans, you're not likely to get ones that are related to each other. Again, a small random sample from a very large population usually passes the independence requirement. All right, so I think we're good there. All right, so now let's take a look. Our test statistic was 17.3766. Our critical value was 9.48. Now remember, goodness of fit is a right-tailed test. So the tail is going to start at 9.48 at the critical value. And again, our test statistic is definitely going to fall in the right tail because 17 is a lot bigger than 9.4. So it is significant. Also, we're seeing that the p-value is very low, right? Close to 0.0016. That's 0.16%. All right. So again, if you're trying to explain that test statistic, the sum of the averages of the squares of the differences between the observed sample counts and the expected counts from the null hypothesis is 17.3766. Again, that's really just the definition of chi-square. Our critical value was 9.48. So our test statistic, let me fix that. Our test statistic of 17 does fall in the tail determined by the critical value, so the sample data significantly disagrees with the null hypothesis. Remember, that would also tell me that the observed counts, that's the sample data, significantly disagrees with the expected counts. Remember, the expected counts is sort of a representation of what we expect to happen if the null was true. Our p-value was 0.16%, so if the null was true, there's a 0.16 probability of getting the sample data or more extreme by sampling variability. It's a low p-value, so it's unlikely to have occurred by sampling variability if the null was true. And we reject the null hypothesis, right? Remember the low p-value, we reject the null hypothesis. But the null hypothesis was the claim, right? So we're really rejecting that claim. So we're rejecting this article. We think the article, this, or at least sample data, is significantly contradicting it. So there is significant evidence to reject the claim that 43% of Americans like football, 23% of Americans like baseball, 20% like basketball, 8% like hockey, and 6% like soccer. Okay, so that's our, this is Matt Touchot with intro stats, and this was problem number 30 in section 4D.